Hello students, today we will discuss on the formation of standing wave in the string, and first we derive the expression for the equation of sound wave in the string by producing a incident wave and the reflected wave. Okay, let we have a string which is stretched at two ends. These are the knots. When we create disturbance at middle, we observe that a compression is moving, and at the boundary or at N2 point it reflected as rarefaction and reached to point N1, and this position is continuous. This is point of antinode. Okay, let the displacement of the incident ray is A sine omega 1t minus k 1x minus kx. This is first displacement, let's say y1, and displacement of reflected ray is y2 a sine omega 2t minus plus kx, as we discussed earlier, where y1 and y2 are displacements of incident and reflected wave. Okay, now according to principle of superposition, resultant displacement y is given by y is equal to y1 plus y2. Now substituting this value, a sine omega 1t minus kx plus a sine omega 2t minus kx. Okay, okay, now student, we have here a formula for sine a plus sine b is 2 sine a plus b by 2 into cos a minus b by 2. Okay, therefore by using this formula here, we get y is equal to a is constant, and for this 2 sine omega, because frequency is same, here we use only omega. Okay, so it is only omega, not omega 2. Omega t minus kx and plus omega t plus kx upon 2 into cos omega t minus kx and minus omega t minus kx by 2. Here we observe, when this plus multiplied, minus kx cancel by plus kx, and for this when minus multiply, minus omega t is cancelled by this. Okay, this is plus. Therefore we get a 2a sine omega t plus omega t 2 omega t upon 2 into cos minus kx and minus kx minus 2kx upon 2. Okay, this 2 cancel, and next we get 2a sine omega t into cos kx. Here cos minus kx in the fourth quadrant, which is positive, cos kx. Okay, this is the displacement. Now here y is equal to a sine omega t is oscillatory function. Here a is equal to a cos kx. Okay, now this is the amplitude and this is the equation of standing wave in the string. This is, let's say, equation A. Equation A is required standing wave in the string. Okay, now here for amplitude which is capital A equal to 2a cos kx. Okay, have two situations, that is a0 or a maximum, that is 2a. This is maximum and this is minimum. Okay, for minimum we called node or formation of node, or for maximum we called formation of anti-node. Okay, for node is called constructive superposition. constructive superposition. And for antinode it is called destructive 1 minute. Yes, this is destructive. And this is constructive superposition. Okay, superpositions. Now we understood about the two types of equation or formations. Okay, for a node, that is amplitude A equal to 2A cos kx. Okay, for node kx equal to 90 degree. This is called path difference. Okay, kx is 90, that is pi by 2. Okay, therefore if we use here this 2a cos kx 0 for n pi by 2. Okay, so in y is equal to 2a sin omega t cos kx for kx equal to 90, kx equal to 90 degree. This y become 0, that is it is a node. It is a node point. Okay, for this cos kx equal to pi by 2, or for every multiple of pi by 2, that is every odd multiple of pi by 2, that is 3 pi by 2, 5 pi by 2, cos kx become minimum equal to 0. So we get a result for it 2n minus 1 pi by 2. This is the path difference. Or we can say that cos 2n minus 1 pi by 2, that is kx, which is a path difference between two consecutive nodes, is 2n minus 1 pi by 2. Okay, now, and as you know, k is wave number, which is equal to 2 pi upon lambda. So you can calculate this in place of k, 2 pi upon lambda, x is equal to 2n minus 1 pi by 2. So you can easily calculate from here lambda. This lambda is equal to, this pi cancel, and 4 x upon 2n minus 1. Okay, this is wavelength for the node and for antinode. Cos kx equal to plus 1, which is equal to cos 0, or the angle for which the value of cos is 1 is cos n pi. Now we can conclude from here kx is equal to n pi. By using value of k, 2 pi upon lambda, we get x is this lambda. Therefore we get lambda is equal to 2x upon n. Okay, this is the value of first length. Okay, these are the constructive and destructive superposition for which we get the position of node and antinode. Thank you. Okay students, next we have standing wave in string and normal modes of vibration, or musical mode in strings. Okay, now consider a string of length capital L fixed with its two ends. Let a continuous sound wave send towards positive x direction or right, whose velocity is given by v is equal to distance upon time. Here students, we have a relation: velocity or speed of sound is equal to nu into lambda, or product of frequency and wavelength. Here we can define frequency by this letter nu, or as well by this f. Therefore we can conclude that the frequency is equal to speed upon wavelength. Okay, now the speed by Newton's formula is given by square root of t upon mu. Okay, t upon mu, where mu is mass per unit length. After completing this, first we have the first normal mode of vibration or fundamental note, first harmonic or basic tone. Now consider a string of length L. This is the length of a string L. By creating a disturbance, okay, these are the node and the center is antinode. Okay, now the distance between crest node to the another node is lambda by 2, as we learn in the characteristic. Therefore we compare the length from the figure. From figure, length of a string is equal to, in the term of lambda, is lambda by 2. From here we calculate the value of lambda, which is 2L, by multiplying 2 here. Okay, now from equation first, frequency, or let's say f1, is equal to v upon, in place of lambda, is 2L. Here we have the velocity 1 upon 2L equal to T upon mu. Okay, so students, here this F1 is equal to 1 upon 2L under root T upon mu is called nu naught. That is, nu naught is equal to 1 upon 2L under root T upon mu. This is called first harmonic. First harmonic or basic note. Basic tone. Okay. Second normal mode. Second normal mode of vibration. Or we can also say second harmonic. Okay, for producing the second harmonic, in the same string of length L, by making a node at center. Okay, this is N, this is N, and this is another N, like this. This is the another N, and these are antinode. So in the second harmonic, two antinodes. Now this length L of a string is equal to crest to trough is lambda. Okay, therefore length is equal to lambda. Now by frequency is F2 for second harmonic is from the same formula 1 upon lambda, and velocity is T mu. Okay, by using this value of lambda, 1 upon L under root T mu, by multiplying 2 to get a natural tone, 2 into 2, we get F2 is equal to 1 upon 2L into 1 upon 2L under root T upon mu. By multiplying here 2 into 2, so this 2 is in multiplication, and this result, that is 1 upon 2L under root T upon mu, is the second harmonic, that is 2 nu naught, because we have nu naught is equal to 1 upon 2L under root T mu. Okay, this is second harmonic and first overtone. Okay, now third harmonic. for third normal mode of vibration. Again, same. In a string, if we create two antinode, two notes in between, then the wave is traveling in such a way, and then it return back. Okay, and in this we get three antinodes. Okay, so the length of a string L is the sum of 1 lambda and lambda by 2. Okay, therefore from figure we observe that L is equal to lambda plus lambda by 2, which is 3 lambda by 2. By calculating length in term of lambda, so we get 2L by 3. Therefore frequency of third harmonic is F3 1 upon lambda under root T mu. By putting the value of lambda here, we get 2L by 3 under root T mu. By solving this, we get F3 is equal to 3 1 upon 2L under root T mu. This is, we have value of the basic tone, which is 1 upon 2L Tm mu. By using this value here, we get F3 is equal to 3 nu naught. This is third harmonic, frequency of third harmonic, and second overtone. Okay, hence we observe that the frequency the wavelength of nth mode of vibration of a string is lambda n is equal to 2L upon n. Therefore frequency of nth harmonic is 1 upon 2L upon n under root T upon mu, which is n 1 upon 2L under root T upon mu, which is Fn is equal to n nu naught. Okay, that is, this is frequency of n time n times the fundamental or basic tone okay. The note so produced is nth harmonics and n minus 1 overtone. Okay, here we observe that in the string all the normal modes of harmonic and their respective overtones can be produced. There with their frequency ratio. Ratio 1 ratio 2 ratio 3 ratio 4 and so on. Okay, this is the production of musical modes in the string. Thank you.